Solve the following quadratic equations by factoring. So this first example is one of the easiest examples of when we can factor a polynomial, if it will factor, because not all quadratics will factor. The reason that this is the easiest case is because this leading term coefficient, so the coefficient on the x squared term is equal to 1. When that's the case, all you have to do is find two numbers that add up to this middle term and multiply to this constant term. So two numbers that multiply to -6. We could use 1 and 6, but I think I'm going to try 3 and 2 first. And what we need is for these two numbers then to add up to the coefficient on x, which is +1. So I think if I have +3 and -2, that should work out because these would multiply to -6 in particular, but then also add up to +1. So that's great. It's factored. Now the next thing is to just take each factor. This is known as the zero factor property. Set each of those factors equal to 0, and that turns this into two separate linear equations, and you can solve these linear equations by setting them to 0 and getting x by itself. Next here we have 3x squared minus 11x minus 4 equals 0. And this is a slightly harder example because this leading term coefficient is not equal to 1. If that's the case, we can't simply look for two numbers that multiply to -4 and then add to -11 because we have to consider this coefficient here. There's lots of different ways of doing this. I think one of the easiest ways, especially if one of these two numbers happens to be a prime number, is just the guess and check method. So what we'll do is draw out two sets of parentheses here and find two things that will multiply to 3x squared. Well, the only possibilities there are 3x and x. So I know that my first two terms in these factors has to be those values. Now the possibilities for 4, I could have 1 and 4, or I could have 2 and 2. Not a lot of possibilities here either, but I might have to try a couple to see what happens. All right, so let's start off with 2 and 2. All right, if I use 2 and 2, then what happens here is 2 times x gives me 2x, and then 2 times 3x would give me 6x. So those could add up to 8x or possibly like 4x, but I can't get them to 11x. I need to get that middle term to work out. So let's try some other possibilities. So 1 and 4. And if I try 1 and 4, then perhaps it's 1 here and 4 there. Let's see what happens. So 1 times x is just x. 3x times 4 is 12x. Now, if the 12x were negative and the x were positive, they would also add up to -11, which is great because then to make 4 times 3x result in a negative value, I can just put a negative in front of the 4 and a positive in front of the 1. And now I've got this factored. So just to double check, 1 times -4 would give me -4. And then this middle term is adding up to -11. 3x times x gives me 3x squared. So that's great. Now, I just need to use the zero factor property, set each of these factors equal to 0, and continue solving. These are both linear equations now. All I have to do is get the variable by itself. So in this case here, I'm going to subtract 1 from both sides and then divide both sides by 3. And in the other case, I will add 4 to both sides, and I have my solutions at -1/3 and +4. Lastly, in this group, we have 6x squared plus 11x minus 10. Now, this is probably going to be even more challenging because neither of these numbers, the leading term coefficient nor the constant value, are prime values, which means there's probably going to be a lot of different possible combinations that we could work with. So we can always do guess and check. That's fine. Uh, some instructors at this point use what's called the AB method, which means you try and find two numbers that multiply to the product of 6 and -10, and then add up to the middle term, which is 11. So you try and find numbers that work for this, and that's generally sometimes a little bit easier. And once you do that, you can set it and do it by factor by grouping. I'll do that in a minute if this process doesn't seem to be leading anywhere, but for now, let's just try it. All right, so 6x squared. I could use 3 and 2 or 6 and 1. I generally go for the values that are closer together first, and that seems to be the way that most quadratics are set up. So we'll just see. All right, 3x and 2x multiply to 6x squared. And then for 10, I will use 5 and 2 because I could use 5 and 2 or 10 and 1. Now, I'm not going to try 5 and 2 here because this gives me a common factor among one of these linear terms. But for that to happen, I would need a common factor of 2 within the original quadratic. So I'm guaranteed that that's not the way that this is going to work. So let me try this set right here. All right, so 2 times 2x would be 4x. And then 5 times 3x would be 15x. And if I have a positive 15x and a negative 4x, they would add up to 11x. So this is working out great. So positive there, negative there, and now I can continue solving. So I just take, using the zero factor property, I take each factor, set them equal to 0, they will become linear equations, and I can solve each of those linear equations separately to get my two solutions. So adding 2 to both sides here, this would be 3x equals 2, and then divide both sides by 3, I get x equals 2/3, and then in the other, 2x equals -5 by just subtracting 5 from both sides, and then dividing by 2, I get x equals -5/2. Now, if you would like to see the alternate method, that AB method that I referred to, you can continue watching, or if you're comfortable with what I just did, you can stop the video now. All right, so the alternate method here, just so you see it, again, I'm looking for two numbers that would fit this criteria. So multiply to -60, the product of the leading term coefficient and the constant, and add to 11. So I generally do have to try some different possibilities until I can get those. But 60, let's see, we could have 6 and 10, but there's no way to get those to add to 11. How about 2 and 30? That's not going to work either. 3 would go into it, 3 and 20, that doesn't look right either. 4 and 15, those look good if the 15 is positive and the 4 is negative. All right, so that basically is all the guess and check. That's all finished at this point. So now what I do is I take the original polynomial, 6x squared plus 11x minus 10 equals 0, and I decompose this 11x into -4x plus 15x. So that gives me 4 terms in this polynomial instead of 3, or the quadratic, I should say. But these 4 terms, I can group together the first 2, and I can group together the second 2, and there's going to be some common factors among these groups. So let's pull out those common factors. So among 6x squared minus 4x, I could pull out 2x, and that would leave me 3x minus 2. And if I pull out a 5 from the second set of parentheses, that would also leave me 3x minus 2. Then, at this point, if you'll notice, 3x minus 2 appears in both terms that remain. So it's a common factor. And you can always pull out a common factor. And if you pull a common factor of 3x minus 2 out of this full term, you're left with 2x. And if you pull it out of this full term, you're left with 5. So clearly there's more steps involved in this alternate method, but some students actually prefer just doing all the guess and check right here in this little part and then going through these steps in order to get the factorization. And of course, at this point, you would set each of these factors equal to 0, and you would still end up with the same solutions. But how you arrive at those solutions is slightly different based off of the method of factoring that you've chosen.